This is Software Engineering Radio, the podcast for professional developers on the web at se-radio.net. SE Radio is brought to you by the IEEE Computer Society and by IEEE Software Magazine. Online at computer.org/software.
Welcome to Software Engineering Radio. I'm your host, Jeff Doolittle. In this episode, I'll be discussing Waterfall versus Agile methodologies with Jeremy Miller. Jeremy is a senior software architect at Calavista Software. Jeremy began his software career writing shadow IT applications to automate his tedious engineering documentation, then wandered into software development because it looked like more fun. Jeremy is heavily involved in open source .NET development as the author of Structure Map, Storyteller, and as the lead developer of Martin. Jeremy occasionally manages to write about various software topics at jeremydmiller.com. Welcome to Software Engineering Radio, Jeremy.
Hey, thanks, Jeff. Thanks for having me on today.
Yeah, glad you're here. So we've been talking for a while about some projects that you've experienced throughout your career, and you mentioned to me recently that you spent the last year or so working on a team using what you described as a waterfall approach to software development. So can you start by explaining what you mean by waterfall and maybe how this particular project contrasted with other projects you've worked on?
Sure. And first off, what I want to bring up is the organization we're doing this within. It's just early in their migration and adoption of Agile processes and practices. So that this is a starting point; it's not the end point. And weirdly enough, I have seen a process like this before. So going all the way back to classic waterfall. I'm going to build up what sounds like a straw man, but folks actually do this.
Okay.
So the idea with a waterfall is that you are able to do things in phases in a linear fashion. The idea that the metaphor of software development as construction. The business analysts talk to the business and they go out and they gather requirements and then they write up a document describing all of these requirements. Then they bring on the architects. The architects talk with the BAs a little bit, and they design a technical design specification. Then they hand that off to the developers and tell the developers, go build this. When the developers feel like they have it complete, or more likely, when the schedule says they're supposed to be complete,
Right.
Finally, at the end of this, testers come on and read up on the original business requirements, and they test those requirements against what has really been delivered. The problems coming up right off the bat is communication and context. It is quite possible that the analysts and the business were never on the project at the same time as the tester, or not very actively on the project. Same thing, the developers may not have been overlapped much with the business analyst or even the architect. So the information is being conveyed in about the least efficient way possible by dropping off documents that haven't necessarily been proven out by any kind of feedback. As an architect, I know full well that a lot of my designs early on are best guesses, and they have a tendency to grow and adapt and change as soon as you get into the real development. The waterfall process may not give you a lot of chance to do that adaptation. So some of the problems you hit, shops that buy in really hard to the idea that the waterfall actually works. As soon as the BA is done delivering their design, their requirements documentation, they'll go off and work on a completely different project. Same thing with the developers. So what you have happen is at no point are all of the people who are contributors to a project focused on the same project at the same time. When you get into testing, you start getting bugs. The developers may not remember much about the code. I've faced circumstances in the last couple of months where we have had to unwind problems in code that had been completed, according to us, up to a year earlier.
Wow.
So that splitting context, the lack of communication, and just the lack of flexibility to recover from early mistakes, whether in designs or requirements, is extremely problematic. And that's what Agile was originally meant to address and change.
Okay. So to kind of summarize some of what I heard you say, first off, it sounded very linear, like it's sort of a forward only approach. And once we've moved from one phase to another, there's sort of no going back.
Exactly. That's the theory. It never works. It cannot work like that. But in theory, that's how it's supposed to work. And the problem is the shops completely build their organizational model around the idea and concept that waterfall actually works and you don't go backwards.
Right. And you also mentioned that as you get further along in the project, it sounds like key stakeholders and decision makers are no longer available in your experience to possibly answer critical questions or help maybe manage through a potential change to the project.
Yes, exactly. Or even if they are, they're cold on the project. It may be something they worked on 6 months earlier and they just flat out do not remember the fine grained details.
Right.
Or testers and developers, they're not learning about the project at the same time. So there's a lot of potential waste when developers and testers interpret requirements documentation differently.
Hmm. Yeah, for sure. So you mentioned construction, and I know you sort of caveated what you were saying and saying that in a way you were building up a bit of a straw man, though it's similar in your experience to things that you've been a part of. But it's interesting because when I think of construction, it seems like typically the architects and the contractors are available throughout the life cycle of the project, and there isn't sort of a disappearance of those people from the scene. So I'm just curious, is that analogy accurate in the sense of do waterfall projects maybe work differently from construction projects in that regard?
They work differently. So just ironically, so I actually have a background in construction. So I actually started as an engineer before I got into software. So I'll give you two. I'll give you two experiences. One, helping build a house where no, the architect was not involved
Okay.
whatsoever. We just had plans. And on the hottest, most humid July afternoon you can possibly imagine, building a roof over a garage and getting it most of the way done. And the foreman of our crew suddenly looks really concerned, looks around, and realizes the plans are just drawn incorrectly.
Okay.
So out comes the reciprocating saw, and we have to take the roof that we just built. We have to take it down and raise it up 6 to 8 inches because the plans were wrong.
Wow.
Right.
Wow.
So there's a problem there for software of there are some things that you have to be very, we'll talk about this, I know, a little bit later when we get more into the agile side of things. Construction, some things have to be done correctly up front and decided because it's really hard to change your mind. It hurts to build a roof and then to have to take it down because you didn't build it high enough, you didn't design it high enough. That's a negative example. On a more positive example, so out of my first job out of college, I was an engineer helping design and build petrochemical plants. And there was a lot of give and take between, even near the end, between the engineering side and the construction side. When the construction side would occasionally find things that couldn't be built or just couldn't be right. Not many, but some. But we were able to accommodate that because we had a three-dimensional model of the entire piping, of the piping through the entire plant. And we could go and we could very accurately model how was it going to work in the physical work. And we could check it out and test it out before anybody physically tried to do that. In the software world, I'm not sure we can accurately predict how things are going to work strictly from paper. Some things we can. A lot of things actually need to be built.
Okay. So maybe part of the design process of software, it sounds like you're saying, requires some amount of actually building to see how things will function together. Whereas in some of the engineering discipline that you participated in the past, you were actually able to model things prior to actually building them.
Yes. Or to drive this home a little bit of why software is not like construction. When I was an engineer, we used something called the boiler code. That's a set of engineering standards for piping, pressure, and all the making things safe. That code, it's evolved over time, but that code traced back to, I think, the 1880s.
Okay.
Because the basic properties of stainless steel has never changed and will never change. They're very well understood. As a software developer, I think it's very unlikely that you're going to be using the exact same set of libraries, tools, versions of everything from 2 projects in a row. You're going to be dealing with unknown materials all the time.
Yeah. So can you think of a project that used a waterfall methodology and they actually tried to rationalize using that as their approach in your experience?
I can. And I'm going back, I'm going to be going back to the early 2000s here.
Okay.
But so going back to the time before Agile development. So part of the rationale behind a waterfall, it's really up to some of it is at the organizational level. The idea that we have a finite amount of resources, and resources means us, but we have a finite number of certain types of skill sets. And rather than having some of these specialized skill sets tied down on one project, what if we could arrange the process in the entire 300-person organization such that we can most efficiently share these skill sets and cover more of these projects? And the way we're going to do that is we're going to rationalize software as kind of a manufacturing factory line of the business analysts are going to come on, they're going to come up with the requirements, they're going to work with the architects, they're going to create a high-level plan, technical plan. The architect is going to work with the technical lead, and they are going to create a detailed technical specification. And then finally, the developers can be loaned onto the project, and they will quickly build the spec. And then from there, it turns over to the testers. So at no point do you have to have all of these specialized skill sets tied down on one single project, with the idea and the hope that you can share these skill sets, kind of renting people out to project initiatives and try to do much more, many more things in parallel.
So the rationale there would be that it's an attempt to try to share resources.
So there may be a second big thing. The first was a way to share resources and be able to theoretically parallelize more initiatives across their organization. The second is just kind of maybe an older idea. So folks that come from older platforms, especially thinking about people that came from C++ or COBOL or pure database development, where code was really kind of risky and hard to change, that came up with this idea that writing software, it's kind of like pouring concrete. That, first you need to figure out exactly what you're doing, because if you don't get the concrete forms exactly right, you've completely messed up. But you build your plan of exactly what you're going to build. So taking this analogy farther, you build the concrete forms, and then you just pour the concrete and let it dry, and you're done. With the idea that once the concrete is poured, you can't really change its shape. So a lot of Waterfall is based on this idea that you have to know everything up front or you'll never be able to get anything done.
Right.
So a lot of Waterfall was based on the hope that if you did enough diligence up front, enough, this is back in the days too, when unified modeling language was popular. If you did enough diagrams and enough reviews, that you could weed out the problems with the approach, and you could hand over a proven out set of specifications that could just then be built. That at that point, coding was just a mechanical exercise of typing.
Right. Okay. So before we move on to really get into Agile, I feel like you've set a good foundation for us for your experience with Waterfall. But are there any positive practices in Waterfall that you've seen that might be worth emulating? Or is it all, in your experience, needing to be replaced or subsumed with different practices?
Honestly, the only thing that I think would be appropriate, or the only place would be appropriate for Waterfall, in my opinion, are projects where budget isn't necessarily a concern.
Okay.
And the canonical example is somebody in the crowd is going to say, but the Apollo spacecraft software was written with the Waterfall.
I've been waiting to bring that up, so thank you for bringing that up yourself.
And that's obviously going to come up. But they were also writing in a way, they weren't writing a lot of user interface stuff. They didn't have the same budget constraints that you and I have on your projects. And I would be very careful saying, well, it worked for Apollo, it'll work for me. The other places, so there's a little bit of a Heisenberg uncertainty principle around software processes. The act of measuring progress and controlling progress and estimation has a tendency to slow you down. But in theory, you can be more predictable sometimes with Waterfall, or you can at least feel like you are. So if there's some kind of regulatory aspect to it where maybe you need industry auditors to come in and validate your approach before you start, that's probably going to push you more to Waterfall. But when we start talking to the Agile stuff, the reality is it's a spectrum, and very few projects are going to be at either extreme pole.
Right. Okay. Well, that's a good segue then for us to talk about Agile in relation to Waterfall. So first off, when did you first encounter the idea of approaching a project using an Agile methodology? Do you remember?
So in the very early 2000s, I was in my very first official IT job. And I was very inquisitive about the world of software development. And I started stumbling on some books really about the old Rationale unified process.
Okay.
Some of the very first iterative process. But shortly after that, I stumbled onto some of the initial writings about extreme programming. And it just sounded like such a much better way to do things than what we were attempting to do with my hard and strict Waterfall shop. Shortly after that, I was fortunate enough, I was able to jump straight from big IT Waterfall into a small consultancy that was a very early adopter of extreme programming.
So your first experience in particular had to do with extreme programming, which maybe explain for our listeners, what's the relation of extreme programming to Agile and what maybe distinguishes it from other Agile methodologies?
Sure. So extreme programming was a very early Agile process that was very influential. I know there's a few shops that still do it today. There's still XP clubs, book clubs, and meetups. But it was extremely influential before Scrum took over and pretty well wiped everything else out. The biggest differences between extreme programming and Scrum for me is extreme programming was quite a bit more developer-centric, focused a lot more on engineering practices than Scrum does today, and was probably a little bit more built on philosophy rather than having more detailed project management structures and strictures like Scrum does today. But at the time, it was a very vibrant community, and it just felt alive. Like we are finding better ways to get software done. And in practice, and I should say very clearly, I did have some very negative experiences with extreme programming, but in the whole, it was a much friendlier kind of environment to work, and it was much easier to get things done.
Okay. So extreme programming has some certain practices around it, from my understanding. Can you maybe explain what a few of those are and how they sort of fit within that particular methodology?
Sure. So some of the more famous things. It was one of the first formal methods to come up with the idea of iterations.
Okay.
So a lot of the philosophy and the driver from this was the idea that we want to work in an evolutionary fashion. So we want to be delivering features early, but when we delivered things, we wanted to deliver, there was an idea that you wanted the features you were building in each iteration to be done, meaning they were potentially able to be released into production.
Okay.
So not just write code for months and months and months and then test, but combine all of the phases, the old traditional phases at one time. So we're as quickly as we can, we move from analysis to coding to testing for just a little bit of the system at a time, and then move on.
Okay. So iteration, testing, being adaptable. Maybe you didn't mention this specifically, but it sounds like the drive to get something shipped early would be to also get customer feedback earlier in the process and maybe be able to turn that back into changes to the design. Am I catching that correctly?
Absolutely. So one of the killer problems with Waterfall is you knew much more about how the project should have worked at the end. Some of the better ideas came very late. The user feedback you got very late it just came too late to improve the project. So XP, or really any iterative process, is built around the idea that you learn as you go. So try to maximize your ability to take advantage of what you learn as you go instead of committing to what might be the wrong plan, the wrong requirements, the wrong architecture too early.
But we have to follow the plan.
Yes.
Okay, so there's something you haven't mentioned yet about extreme programming, which I find interesting because the first thing I think of with extreme programming is pair programming. So in your experience, has that been an integral part of XP, or has that maybe been overemphasized in my mind or others? Or how does that fit in your experience?
In the very early days, I'll admit it's been years since I've done projects with a lot of pair programming. But the real driver, so maybe back up just a tiny bit into the organization. So there was an ideal as part of extreme programming that you wanted collective code ownership. And the real driver there was the idea that you did not want people specializing in one area of the code. Okay. You never wanted one piece. As much as possible, you did not want that area of the code of, oh, that's Joe's code, that's Mark's code, that's Sandra's code. You wanted, as much as possible, you wanted developers to be able to move between areas of the code. So there were more eyes on the code. People had a better shared understanding of how the code is working and how we're building so that more people could be effective in building the system, which also has a little bit of a side benefit of being more adaptable on what you can take on if more people are able to work in different areas of the code.
So a couple of questions on, well, I guess first off, as you're saying that, it reminds me of the book, the Phoenix Project, and the guy Brent, who is the bottleneck for everything because he has all the knowledge and the information. I'm not sure if you're familiar with that book, but I'm sure many of our listeners are familiar with that concept. If you have a single person who has all of the sort of tacit knowledge in their mind, and when they're overloaded or unavailable, nothing can get done. And it sounds like XP is trying to avoid that kind of a problem. Is that correct?
It's explicitly trying to avoid that, and pair programming was a way to do that.
Okay.
There was also the belief that pair programming was a way of having constant code reviews.
Okay.
To keep people kind of on a good path, to keep people from, when you're by yourself and you're maybe not getting a lot of feedback on your design or approach, maybe you overcomplicate things. Sometimes having two people, it'll catch edge cases, maybe oh no, you could just do it this way. You don't have to do this elaborate thing.
I see.
Go ahead.
So in a situation like that, like you're explaining with XP, it sounds like the goal is to have people be very interchangeable, but what do you do about the fact that different people have varying areas of expertise or maybe specialization around technologies or portions of the technology stack? For example, database versus algorithmic programming versus user interface development. How does that play out in an environment like that?
Sure, and I'm glad you asked that, because that's really important. It's a very important difference between the old-fashioned waterfall I was describing and what we have now. So one of the points of emphasis in extreme programming that I still think rings very true today, the very best teams, the teams that are most productive, are self-contained teams with multidisciplinary people that have every skill set that is needed to deliver their project is part of the team, right? So if you think about some of the things that make software development slow for us, it's external dependencies. It's needing to have formal handoffs with other people, needing to collaborate with people from outside of your organization, or just you and I having to interact with developers with completely different skill sets. So one of the things that happens that can be very problematic. So right now, I occasionally have to integrate, or some of our client projects right now, we're helping integrate some brand new .NET Core stuff to much older .NET Framework stuff to IBM iSeries mainframe code written in RPG. So just as a recent example from the last couple of years, some of the teams and projects I work with, we're helping a client integrate some new .NET code with old IBM iSeries applications. And we get along just fine with the RPG developers who work on the iSeries, but we don't have a lot of words in common. It's hard for us to communicate because I don't think either side really understands how the other works, and it has been a real problem in our ability to collaborate. So, taking that back to just how do you deal with how I, as a front end guy, deal with web developers, which that's kind of a joke. Nobody lets me do UI work, but UI developers talking to middle tier people, talking to database people. So that waterfall world, those different kinds of developers, they could conceivably be in totally different teams because you have the specs, everybody coded the spec, and it all works and it all combines together. Except that never works. In an agile process, especially in the extreme programming days, you wanted a multidisciplinary team. You wanted very close collaboration between all these different people. So maybe I don't understand every technology, but if I'm pairing, especially when we're crossing the boundaries and integrating front-end code to back-end as an example, if we're working together, we might have a much better chance of getting a smoother collaboration. Coming back to some of my very early days, actually going all the way back to being an engineer, again, building these giant petrochemical plants. It takes a lot of different types of engineers, piping engineers, pumps engineers, the various kinds of chemical engineers, civil engineers. One of the things I had impressed upon me very early is when you're communicating with all these other types of engineers, you need to understand a little bit about what they do and how they work so that you know best how to give them the information they need by understanding how they're going to consume what you tell them. And then on the backside, if you're understanding what they're telling you about their work and how it impacts your designs, that's the way to be most effective. And that is absolutely true with software development today.
Yeah, I just heard an interesting phrase the other day called technical empathy. And it sounds similar to what you just described in the engineering world, where the idea is you should have empathy for the person who's downstream from the information that you provide or the APIs that you publish. And that definitely improves communication between different parties, especially as you said, where maybe their knowledge domains are disparate and distinct to some extent.
I'd never heard that, but I like that. Yeah, I think that's very apt.
So we've talked about extreme programming, and a little bit before you mentioned Scrum, and it sounds like a lot of your experience with extreme programming was maybe a little further back in your history, and maybe more recently you've experienced other projects that have run in different ways. So maybe there's other agile methodologies besides XP or Scrum, but maybe speak to a little bit about how you've seen the agile landscape evolve over the last, say, 10 years or so.
Well, so 10, 15 years ago, there were a lot of different agile processes. There was a whole family. There was extreme programming, Scrum, something called Crystal.
Right, from Alistair Coburn.
A lot of things. Yeah, a lot of things I don't even remember anymore. But by and large, Scrum has completely won out. And most of the people that I work with that have joined the industry in the last 10 years that really believe that Scrum is synonymous with Agile at this point.
So maybe talk about that a little bit. What distinguishes Scrum from extreme programming? Are there any shared approaches and any distinctive approaches that separate them from one another?
I'm a member of Generation X, and one of the cultural touchstones for me as a small child is watching Scooby-Doo on Saturday mornings and after-school
Yes.
reruns. And Scooby-Doo had this great model for years, and then one horrible day, the new season started, and there was this new character called Scrappy Doo that changed everything. And Scrappy was really annoying, and it ruined Scooby-Doo for millions of Generation X kids. To some degree, especially for those that came out of the idealistic world of extreme programming, Scrum is the Scrappy Doo of Agile software development.
Well, if you're going to throw out a Gen X reference, you might need to provide us some links so that listeners can go and find out who Scrappy Doo is. Maybe better said, he's the Jar Jar Binks of Agile programming.
Oh yes, that's probably more apt.
That's kind of an old reference too now these days, which is shocking. But I digress. So okay, now there may be people that are using Scrum and feeling like, or maybe even having good experience with it. So you're going to have to unpack that a little bit. That might be a controversial opinion.
Oh, I will. But what I need to say is your mileage is going to vary. And I have absolutely no doubt that some folks out there are doing very well with Scrum.
Okay.
And some people are running off the road. So Scrum, and I should admit, Scrum is actually older than extreme programming. But Scrum did not become popular until the Agile development kind of maybe craze of the early 2000s. And I think Scrum took off because of the Scrum Certified Master Program, the CSM, the kind of formal programs that you can get for certification around Scrum. And Scrum has much more focus on project management, which I think made it very popular and palatable for manager types. And but the problem with Scrum, not to say that the performative ceremonial things in Scrum, the stand-ups, the sprint planning, the estimates, the story poker, those things aren't necessarily bad, but what Scrum left behind from extreme programming was a ton of engineering practices and just thinking about how do we work iteratively? How do we evolve systems without letting things go completely off the rails? Scrum kind of took this attitude of, here are some relatively prescriptive project management practices that you should do. And, oh, by the way, we think you should adopt good engineering practices that will support this style of project management, but we're not really going to talk about how. You guys go figure that out yourself.
So to summarize what you just said, you've experienced Scrum being more project management focused, and maybe there's been an homage paid to the need for good engineering principles, but maybe without having a little more prescription about the how, that often maybe falls by the wayside in terms of importance.
That's absolutely what I have observed. It is what I have also heard from sharing experiences with other people in the industry.
So maybe give some more details about a project you've been on where maybe you saw Scrum in the extreme and the engineering principles that you're describing were not included as part of the process. And what did that look like?
Well, sure. And again, the problem isn't necessarily with what Scrum does, it's what Scrum does not. And the folks that are succeeding they're adding this kind of thinking and process. So building Scrum without a strong set of automated testing or test-driven development, any kind of continuous testing practice. If you're trying to do iterative Scrum, but relying purely on manual testing, so one of the things I had drilled into me in my extreme programming days was during an iteration, you try to dribble stories out to testing as fast as you can. You do not wait until the last day of the sprint to drop everything on testing. You got to give your testers a chance to keep up with you. If you're doing all the Scrum project management, but you're not thinking about how am I going to test this? How am I writing unit tests for this? Am I doing continuous integration to have constant feedback about what's going wrong? If I am not constantly adapting inside of the code, if I'm not taking that step back and saying, this design that we chose early on that worked great for the things we were building early on no longer works. We need to do something different. If you are not doing that kind of constant retrospective kind of adaptation, if you don't have the safety nets of the automated testing, of the continuous integration, then you're going to drive yourself completely off the cliff if you're doing Scrum and trying to constantly churning out new things every 2-3 weeks or whatever it is.
Right. So you mentioned engineering discipline before, and now you mentioned a few what are commonly called in software architecture the illities, right? I heard a couple of those come out. You mentioned flexibility. You mentioned adaptability. Are there other factors maybe that need to be considered up front? Sort of moving away from the Scrum things. It kind of sounds like you could pick on it all day, even though you did concede that it certainly does work for some people, as long as it's not sort of Scrum in a vacuum, right? Without these other things. But maybe in terms of enabling agility, it sounds like it's not just about not thinking or not planning, right? But it's about certain ways of thinking. So maybe what are some of those things that have helped you be successful with the methodologies you followed?
Sure. So I want to back up. We're going to go into a little more of philosophy. So there was an idea. It came from, well, I know it from Kent Beck, but I think it's been stated by other people. This idea that you do the simplest thing that can possibly work. And that's a loaded phrase. It's a loaded idea because what is simple to me and to you and to our other listeners may be completely different things based on what we all know. But inside of a given time, this idea, there's an idea from extreme programming that I should not try to design ahead for things that we do not need at this point. I should not introduce any kind of fancy caching until we have a demonstrated need to do some kind of extreme performance requirements. I should not try to design in flexibility just in case somebody wants to come back and do it a little bit differently or add similar functions. So there's a related concept that's a saying, and it horrified me a couple years ago when I realized that the developers I was working with were very familiar with Scrum project management, but had never heard this. So there's a phrase called Yagni. You aren't going to need it. So the idea that I do not build any kind of infrastructure in right now that I don't need for the features that we are delivering right now. So let's unpack that a little bit because that's going to be kind of problematic. So in a positive way, Yagni allows me to concentrate on solving the problems I need to solve right now, to ignore a lot of other problems that I may face in the upcoming future or the distant future. And by reducing the number of things I have to juggle in my own mind, I'm probably able to be a lot more productive, right? It is generally going to be easier. There's a value judgment here too, that it is going to be easier to change simple code if it needs to be more complicated later than it is to work with complicated code. So that makes it easier for us to focus. There's an obvious problem of what if you need it later, right? So with extreme programming, one of the things we learn, and this applies perfectly well to Scrum or any process, we need to take a lot of investment in making our code easy to change. So if we're going to delay infrastructure, if we're going to focus on just the here and now, but there is a later, we are going to add some of these things later when we need them. So one of the priorities, one of the things that was most important about succeeding with extreme programming is you needed to make it both easy and safe to change your code later. There was a concept called reversibility of, can I change my mind? Can I take an easy approach now, but opt into a more complicated, performant approached later. So with that investment in how do I make my code easier or safer to change, a lot of that was based on the idea of feedback. So, and this is where things like test-driven development, behavior-driven development, where you use business acceptance tests, more automated tests, continuous integration, a lot more project automation that gives you a lot of automated regression testing cycles so that it is now much safer and less risky to change and modify your code. And that there's a lot of discipline to it, but that discipline allows you to evolve a code base over time. And that's what enables you to keep working in an iterative cycle without drowning in technical debt problems.
And I guess from what you just said, that kind of counterbalances that idea of you aren't going to need it, the Yagni. There are things that you are going to need, and you just described what some of those are from your experience. If you want to have reversibility as a characteristic of the system you're designing, then there's certain things you need to do to enable that. And yet, if somebody's just running around yelling Yagni, 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 then they're not really helping you accomplish those things. So what what do you need up front? What are the things in your experience that you really can't compromise on? Because I could imagine somebody saying to you, maybe who doesn't have the experience or has different experience, well, we don't need all of those things you just described. We don't need BDD testing for the business, or we don't need, fill in the blank. How do you kind of navigate those kinds of decisions up front when you're beginning a new project?
Well, it's not so much you need those specific practices,
Sure.
but what you really need are good feedback loops. And the faster you know that you did something wrong or just a theory about how things are going to work, the faster you know that that is wrong or right, you can proceed to either fixing it, changing it, or just moving on to the next thing.
Okay.
So the most important thing, and there are different ways to go about it, but the most important thing is to have really good and informative and quick feedback cycles to let you know I'm on the right track or I'm not on the right track and I need to adapt.
Okay. So adaptability, and you mentioned reversibility. So do you think there's a general consensus on what makes a team agile or not? And if not, why not? Or if so, why?
I don't think I would worry too much about the definitions quite so much, or who is real agile. If we'd had this discussion 10 years ago, I would have given you a very different answer. I would have said, you have to be doing test-driven development. You have to be doing continuous integration. You should probably be doing pair programming, even though I hate doing pair programming, but it's good for you. I don't think I would go prescriptive, but I wouldn't worry about what's real or not, but pay attention to what is and isn't working and take an attitude of constant adjustment. And that means that the team doing the work needs to be both kind of alert to their own circumstances. They need to be constantly thinking about what is working, what isn't working, what they could change. And then your team needs to be empowered to go make those adjustments themselves. We talked about some of the ways that Scrum can go off course. I think one of the most common ways that Scrum fails is when Scrum is used to micromanage developers or testers, when they're not giving a lot of leeway in how they approach their work or being able to stop or change even the way they're doing estimates or requirements. If a team is not empowered to change, they never change, and they probably stop thinking about how they do things. And I think that's when the serious problems creep in.
Right. And now we're just doing whatever keeps the pointy-haired boss off of our case, right? At that point.
Yes. And the pointy-haired boss, he or she may have been a great developer, or project manager, or something in the past, but they don't feel the friction and the pain points that you do because they're not part of it. They don't have a great inside knowledge of what's slowing you down or what helps you all the time. They're not the ones who can most accurately adapt the process or the requirements or the technology.
So let's say I'm a developer or an engineer and I'm working on a team. And whether it's, as you mentioned before, there's no complete waterfall, there's no perfect agile, but there's this spectrum in here. But maybe I have a sense that there's something that we could do differently or better. How have you experienced ways to overcome resistance, maybe to others who either don't see what you see or disagree, or maybe want to say, well, that's not agile or that's waterfall or this kind of thing? How in your experience have you navigated that form of resistance, maybe to some ideas you've had about what you felt would improve process?
Live in Texas now, but I grew up in Missouri. So the state motto is you got to show me.
Mm-hmm.
So it may be a case of you need to demonstrate what you want to do differently. Sometimes you can get away with a little bit of whiteboarding session, but you may have to type something, or you may have to demonstrate, here's how we could do requirements. We could capture requirements differently and make it concrete. To some degree, I mean, there are conflicts, and especially in a flatter team like Agile encourages. I think it's really important you have to learn to compromise. Sometimes you need, especially with a team full of several alpha type personalities, you got to slow down and let yourself listen to the other ideas. Give other people's ideas a chance, let them speak. And sometimes you need to willingly lose an argument.
Why is that important?
Because there are times when someone else's good solution is good enough. And it might also be people understand things differently. There may be an approach that you see that looks perfect to you, and maybe it is, but other people don't understand it. And to some degree, you need to get along with your coworkers.
Mm-hmm.
And when there are times of it may just be I prefer to name variables like this, but the other three of you prefer to do it that way. Try to pay attention to what things are really important and be self-aware about what things are just preference or arbitrary, and be a little easier on things that really aren't that important. And then you can also take the tact of, well, let's try your approach first, but let's also then have an agreement of how do we judge whether this is successful or not, so we can come back and reevaluate this decision immediately after.
Yeah. So being willing to compromise, be flexible, prioritizing what really matters and not making everything the most important battle to wage. But I appreciate that last thing you said about inviting people to creatively think about how we can measure the success of a particular decision. I think that measurability definitely speaks to the idea that we want to be agile, right? And not just do things in a way that somebody told us is something called agile.
Absolutely.
So let's see. What are some ways in your experience that you can actually use agile methodologies to help inform your technology choices?
Oh, that's a good question. So I can think of a couple things. So looking through the lens of this idea we talked about a little earlier called reversibility, my ability to change my mind. Can I pick a technology where I can evolve the system easily? So taking an example of, I'm going to pick on working with relational databases.
Okay.
Versus a project that Jeff and I, an open source project Jeff and I worked on together called Martin, that is instead a document database. If I'm working with a relational database, I do incur a little bit of friction. There is a little bit of impetus to get the data model up front, because there's a little bit of overhead of, oh, I really need to model it this way. And if I need to model it this way instead, I have to change database tables and database scripts and make corresponding changes in my code. If I add a field, if I add a new property to a model object, I may need to go add something to the database, a database mapping in my ORM, and then come up to my code. I have a little bit of a wormhole anti-pattern. There's just mechanical things going on, and it gives me some reason to resist wanting to change the code and to try to get things a little more perfect up front. Taking a different approach, what if instead we used a document database? So document database, a little bit schemaless, but really the database schema is inferred from the middle tier code. In Impact inside of an Agile process, what that allows me to do is it's much, much simpler for me to change and kind of evolve my models because I don't have to do a lot of work to keep the database structure in line. I may not even have to rebuild the database. I may be able to just change my middle tier code and just go. So that kind of reversibility, it is a very big deal. My ability to evolve and not have to be perfect up front is a lot better with a document database versus a relational database in ORM, as an example.
I see. Yeah, you're referring there to what I've heard classically referred to as the impedance mismatch, meaning we have these different models of our system and they don't necessarily easily map to one another. And it sounds like what you're describing there is a case where perhaps if you use certain document database technologies, it can reduce, not eliminate, but reduce that impedance mismatch and maybe help with the reversibility that you're looking for.
Very much so. And that's a big deal. So here's another example. In some web technologies, and I'm thinking mostly older web technologies, it was very difficult to retrofit security or validation in because everything happened in the same blob of code. Think about how awful for us being a .NET developer, how awful web forms was, where everything had to be done together, right? Thinking way ahead now in the world of ASP.NET Core, I can very cleanly, in my application code, I can focus on business logic or data access and completely ignore security requirements at that time because I can always come back and layer in some kind of middleware to add security around my code without changing my code. An example of Robert Martin's old open-close principle. But I have a lot of reversibility that I can retrofit security, either authentication or authorization, by adding these clean wrappers without having to modify my existing code. So that enables me to worry about a few things at a time and to evolve the system.
That does imply that up front you have to make some technological decisions that allow for that kind of approach. So in that sense, maybe it's an HTTP pipelining model or something of that nature. So there's not just enabling technologies, but maybe even enabling patterns that allow you to be more agile and more reversible in your choices.
Oh, absolutely. So reversible technologies, technologies that allow us to be more easily testable, because automating testing is such an important feedback cycle to enable to work in an agile way. That absolutely the desire for reversibility, testability, just the ability to change your mind, all of those inform my technology choices and pattern choices up front. So yes, there is some upfront thinking, but that upfront thinking is really informed by what is going to make it easier to adapt and evolve over time.
Okay. So you've mentioned before that one of your goals in some of the projects you've worked on previously was to try to get features delivered quickly. And just by definition, delivering features means delivering functional requirements. But how do you capture and make sure that non-functional requirements aren't being neglected? Things like quality, things like performance of the system, scalability of the system. How do those various non-functional requirements play into an agile type methodology?
So performance and scalability can still, well, to some degree, performance and scalability, it's still understanding patterns. Patterns are just technology structures. The first order effect is still just us as individuals, how much we know about the platform we're on, the patterns, the communication mechanisms, just understanding the problem domain. That's still the first order effect. Process and practices is second order effect. So we could talk Agile all day, but you still need to know your stuff on the technology front. But scalability and performance are two things that can be measured. If they are requirements that are important enough to justify the investment, you can set up automated testing to measure performance thresholds or scalability thresholds as part of your continuous integration pipeline,
Right.
or your continuous delivery, such that, or at the very least, invest in project automation so that your performance or scalability load testings are repeatable,
Mm-hmm.
so that you can very quickly or relatively easily run those whenever you need to.
Right. So reversibility, repeatability, and being able to make some decisions up front that will allow you to have those characteristics seems like that's pretty important.
Yes.
So you've mentioned your background as an engineer, and my understanding is one fundamental principle of engineering is you want complex things to depend more on simple things and not the other way around. And it seems to me that based on a principle like that, it'd be pretty important to know sort of somewhat upfront what are going to be the more stable parts of your system that you can rely on, and what are the more unstable parts of your system. So how do you make those kinds of decisions upfront, or maybe earlier in your process, so that you're depending on good abstractions that you can rely on? Because if those things change further down, it could really be disruptive to your system.
I don't think I completely agree with the premise.
Okay.
So I would still prioritize having really good feedback cycles and very good automated testing coverage rather than trying to get basic abstractions right up front. I think as developers, I think we have a tendency to go wrong. One of the most common ways for us to go very, very wrong is building abstractions
Hmm.
too early before we know a lot of things. I think it is better to delay introducing or locking into, especially restrictive abstractions, until you get later in the project. But let me throw a big wrinkle into that, because I think I would have been more aligned with the premise of what you asked 5 to 10 years ago. One thing that is I think is different now in a very positive way versus just a very few years ago. I think it is much cheaper, more just mechanically easier to do integration testing today than it was. Thinking about things like trying to do a full integration of your web service stack all the way from an HTTP request to the database. That was a very expensive proposition 10 years ago in terms of manpower to make that happen.
Right.
Today, I think that is much simpler. The introduction of Docker to quickly spin up isolated databases, queue technologies, all kinds of little things. For us, being .NET developers, now that we have Kestrel, that like every other platform, we finally have a web server that can run in process, so that you can, inside your test harness, you can spin up your entire application and run HTTP requests through it and measure the database, changes to the database all in one go. I think that has actually changed the way that I approach design, such that I am less likely to bring on abstractions for the sake of promoting, and I'm doing finger quotes, adaptability or evolvability in my system.
Right.
That I don't think I need to, and I don't need to complicate the code with all these extra scenes that we used to introduce to be able to put mock objects in for automated unit testing. I would forego that, and I would depend much more on integration tests on the outside in than I would have 10 years ago. But I say that because I think the technology has changed the equation so much now that integration testing is much cheaper, easier, and much more reliable than it used to be 10 years ago.
Yeah, and in a way, I mean, I might call that black box testing in the sense that it's opaque. You know what your inflows you know what your inflows are, rather, and you have a sense of what you desire outflows to be. And so what's happening behind the scenes is sort of hidden from you, and you're able to test it at a different level. But you could also argue that that is an abstraction. It's just maybe a higher level abstraction that it's easier to flex with when things change in your requirements.
I think that's a good way of putting it. Fine grained abstractions, especially if you're guessing,
Yeah,
it can hurt you.
absolutely.
When you do make abstractions, you need to be careful what you're generalizing.
Yep.
But that's a very long discussion by itself.
Yeah, that's good. That's good engineering practice right there, right?
So maybe as just a mechanism to get there, focus on really old original concepts of encapsulation and coupling.
Right.
Trying to hide the details of how the sausage is made underneath the sausage casing. That you just don't leak a lot of details. Giving a concrete example from a project I did a year or two ago, working with a web service that was a facade over a third party product. That web service still leaked a lot of implementation details that were peculiar and particular to that third party system, such that even though you were using the web service, you still had to know a lot about that third party product behind it to be
Oh,
able to use
wow.
it. When
Okay.
what you were really doing is saying, I want some loan information or I want to approve this loan. And
Right.
so you weren't able to express that in terms of the semantics of what you were trying to achieve. You had to still speak the third party language to be able to do it.
Right. It's interesting you brought up the idea of encapsulation and information hiding. And there's an article that I'll link to in the show notes by a gentleman named David Parnas, who isn't really well known, but he was actually the inventor of the concept of encapsulation. And it was controversial 40 years ago when he invented it. I'm not sure if I've heard of him before. I'm curious.
No, sorry, I got to admit that I have not.
Okay, well, then you can also be enlightened when I post the link to on the criteria to be used for composing system modules. It's literally the seminal paper on the idea of encapsulation and information hiding. But that's a great point there. That a good abstraction is going to shield you from those kind of things. But obviously, point taken on the danger of making the wrong abstraction or prematurely abstracting. That would definitely fly in the face of making you agile.
Yeah, it's not. It would, but and also two other things. If
Mm,
you're being agile, you constantly adapt. As soon as you realize you're working around an abstraction, that the abstraction is hurting you, or you're downcasting, you need to change the abstraction. Your abstraction
mm,
no longer works, and
right.
it's very possible that it worked in for the early features, and that later things break it. So you got to change the abstraction rather than trying to plunge ahead. Then the second point, and I don't think this is specific to Agile, but when you're creating your abstractions, it's very frequently valuable to create it by pulling what you need out of the client. So one of the old mechanisms for designing low level APIs is you actually build the client first,
Mm,
and as necessary, you mock or stub fake implementation just to define from the side of the client of what it needs, rather than trying to build the API up front with kind of that build it and they will come kind of mentality.
yeah. Well, this has been a helpful discussion, I think, and enlightening for me as well in some ways. So I'm curious if listeners want to learn more about effective software development methodologies, where do you think they should get started?
uh, so I'm going to wander over my bookshelf just a little bit. So even though it's really old, I would still recommend grabbing a copy, or you could probably find a library, Kent Beck's original white book. Let me see if I could find what the name is. But the original Extreme Programming book. From there, I would find an author named Martin Fowler, and I would try to find his book just called Refactoring. And I know there's a recent update of it that's out there.
Okay. Well, is there anything else we might have missed that you'd like to mention in the time we have left?
I'm sure I will think of tons of things tomorrow, but I think it's absolutely worth reading up a little bit more some best practices of designing for testability. I think is a big thing,
Okay.
and I think it's really really important. Don't just depend on a separate DevOps team to understand how all the project automation works. Just
Hmm.
as a developer, make sure you understand the build and test tools that you're working with, and try and make sure you understand how the people around you a little bit more about how they do their own jobs.
Okay. So if people want to find out more about what you're up to, where can they find you on the internet?
So It's unfortunately not as technical as it used to be, but I'm still active on Twitter. Jeremy D. Miller on Twitter. But as much as I try to blog, I am also jeremydmiller.com. You'll find blog posts, a lot of old articles, probably a link to this podcast when it posts. And I'm very active on GitHub with a lot of different projects.
Okay, great. So shout out to people who want to get some open source contribution cred. They can go join up on some of those projects and send in a PR.
Absolutely. I love getting pull requests.
Okay. Well, Jeremy, thank you so much for this discussion about Waterfall versus Agile.
Well, thanks for inviting me, Jeff. This was fun.
Awesome. Well, this is Jeff Doolittle for Software Engineering Radio. Thanks for listening.
Thanks for listening to SE Radio, an educational program brought to you by IEEE Software Magazine. For more about the podcast, including other episodes, visit our website at se-radio.net. To provide feedback, you can comment on each episode on the website or reach us on LinkedIn, Facebook, Twitter, or through our Slack channel at seradio.slack.com. You can also email us at team@se-radio.net. This and all other episodes of SE Radio is licensed under Creative Commons License 2.5. Thanks for listening.